Hi to all. Today's topic is intensity of magnetization and some other definitions I am going to explain. Now, first of all, what is intensity of magnetization? And it is denoted with either capital I. In some of the books it is also denoted with capital M also. Okay, intensity of magnetization is denoted with capital I. In some books it is denoted with capital M, but we already denoted the capital M as magnetic moment. That's why I am not denoting with capital M, I am denoting with only capital I. Okay, right. Now, what is intensity of magnetization? Intensity of magnetization means, for example, any magnetic substance, if you want to magnetize any magnetic substance, this is a bar magnet. In this, so many elementary magnets are there, small magnets, tiny magnets. Every atom will act as a one magnet, but the magnetic moment of all atoms or the all electrons are in different directions. Due to that, all the magnetic moments are cancelled and the net magnetic moment is zero for certain iron or Na or cobalt or any nickel. This is a magnetic substance. In this, the so many magnets are there. Every atom or electron act as a magnet. And now, why? Because electron is revolving, some current is generated, that's why it acts as a magnet. And now this has a magnetic moment, but the net magnetic moment is zero. If this magnetic substance is placed in the external magnetic field, if it is placed in the external magnetic field, external magnetic field means in between the two poles of the magnet or on the axis of solenoid you can keep. Okay, at that moment what happens on these elementary magnetic moments? Okay, then this external magnetic field applies the torque, and due to that all the magnetic moments will align in one direction. Due to that, the net some magnetic moment, this net magnetic moment is not zero. Some magnetic moment is induced in the magnetic substance. This will now it act as a magnet, and now here we are magnetizing. We are magnetizing a substance. Then for that, how intensity of magnetization, right? How much magnetic moment generated in a magnetic substance, that can be measured by a physical quantity, that is the intensity of magnetization. Now, its definition is, in this some in magnetic substance, iron or cobalt, when you want to convert magnetize, then you will place that substance in the magnetic field. When you will place that substance in the magnetic field, some magnetic moment is induced in this, then that induced magnetic moment per unit volume is called as intensity of magnetization. This is a simple definition. When a magnetic substance, what is a magnetic substance? Right? Magnetic substance is a iron, cobalt, nickel, like that. When a magnetic substance, just like ferrous, cobalt, nickel, okay, when a magnetic substance placed in external magnetic field, the induced magnetic field, the induced magnetic moment will be induced. The induced magnetic moment per unit volume, induced magnetic moment per unit volume is called as intensity of magnetization. Intensity of magnetization. Okay, right. This is denoted with capital I. What is the formula for the capital I? That is induced magnetic moment by volume. Induced magnetic moment by volume. This is intensity of magnetization. What is induced magnetic moment? Capital M. What is volume? V. Let us consider. Yes, I am denoting intensity of magnetization with only I, because you may get confusion with the I and capital M. Okay, right. Now the formula for the intensity of magnetization is magnetic moment by volume. Magnetic moment by volume. Right. It's SI unit I want. Then before that, I am taking one substance, okay, just like it is in the shape of like this, okay, parallel pipe like this. This has the length 2L and area of cross section is capital A, right? In this some magnetic moment is induced, that is capital M. Now intensity of magnetization is magnetic moment by volume, but magnetic moment we write as pole strength into magnetic length, by volume we write as cross sectional area into length. Volume of this 2L will cancel, then the intensity of magnetization is also equal to pole strength by area, that is induced pole strength per unit area. So what is M? Induced pole strength by area. What is capital A? Area of cross section of magnetic substance, right? Now SI unit of capital I, SI unit of capital I. What is the SI unit of capital I? Pole strength unit is ampere meter by area unit is meter square. Then we will get ampere per meter, right? Ampere per meter. And the next induced magnetic field. Okay, for example, we are placing one magnet in the one magnetic substance, just like iron or anything. If it is placed in the magnetic field, some magnetic moment is inducing in this. Okay, some magnetic moment is inducing. Induced magnetic moment per unit volume is called as intensity of magnetization. Okay, if more magnetic moment is induced, then more intensity of magnetization, then this magnetic substance becomes like magnet and some magnetic moment is induced. Now it acts as a magnet. It can also produce the magnetic field. That magnetic field produced due to the induced magnetic moment, that is called as induced magnetic field. Induced magnetic field, right? This magnetic substance iron now acts as a magnet. It can also produce the magnetic field, right? Induced magnetic field or induction. That depends upon intensity of magnetization. B suffix in, induced magnetic field. This is depends upon intensity of magnetization. If more magnetization is there, more induced field will be there. Then if when you remove this, we will get a constant, that is mu naught into I, where mu naught is called as permeability of free space. Permeability of free space. Its value is, we know already, that is 4 pi into 10 to the power of mu naught value is 4 pi into 10 to the power of minus 7 Henry per meter, right? Mu naught is equal to 4 pi into 10 to the power of minus 7 Henry per meter. This is about intensity of magnetization. Take a screenshot and note every point. Okay. Next I will continue with the next topic, that is I am going to explain magnetizing field. Here this is magnetization. That means when we place a magnetic substance in the external magnetic field, that magnetic substance, iron or cobalt, itself initially it is not a magnet, but after placing in the external magnetic field it converted into magnetic field magnet. At that moment some magnetic moment induces in that induced magnetic moment per unit volume is called as intensity of magnetization. That induced magnetic moment, that means it is converted into magnet, then only it can some magnetic moment is induces, some magnetic field also induces. That induced magnetic field is depends upon intensity of magnetization. Simply we can also tell it as magnetization. Okay, right. Now let us see the next topic, that is magnetizing field. Magnetizing field. Magnetizing field intensity. Previously what we discussed? Previously we discussed about the intensity of magnetization. But here magnetizing field, that means the field which is used to magnetize a substance. For example, you have a iron bar. That is, iron bar is not basically magnet, but it can convert into magnet, right? That iron bar, if you want to convert that iron bar into magnet, you have to place that iron into external magnetic field. That external magnetic field applies the force and torque and makes the iron to magnet. That means to magnetize a iron rod, some external magnetic field is required, magnetizing field is required. That magnetizing field is definition I am going to explain. Magnetizing field, that means that this is the external field. That field tries to make the magnetic substance into magnet. Then what is the definition of this magnetizing field intensity? Right? It is the ratio between, the definition is the ratio between what? The ratio between external magnetic field, magnetic induction. That means external means applied magnetic induction, right? Applied magnetic induction. The ratio between applied magnetic induction or the field. Induction or fields, both are same, right? The ratio between applied magnetic induction and permeability of free space. Permeability of free space. Is called as magnetizing field, right? This field tries to magnetize. Magnetizing field. It is denoted with capital H. Then what is the definition of formula for the capital H? Capital H is the magnetic induction, applied magnetic induction by permeability of free space. Permeability of free space. Then what is this? How to write this? H is equal to, we write as B by nu naught. H is equal to, we write as B by nu naught, where B is the applied magnetic induction. Applied magnetic induction by permeability of free space. Then, for example, this is a solenoid. Let us take one example for this. Okay, what is the SI unit of this? SI unit is again ampere per meter. The same unit will be there. Okay, right, same as intensity of magnetization. Don't confuse the two definitions. Magnetization, magnetizing field. Then here magnetizing field on the axis of solenoid. I want on the axis of solenoid. On the axis of solenoid, how much magnetizing field will be there? This is a solenoid, right? This is a solenoid. Look at here, some current passes at here. On the axis of the solenoid, how much magnetic field will be there? This is the axis. On this axis, how much magnetic induction will be there? That magnetic induction I want. Then for that, let us see here. What is the magnetizing field? On the axis already we know the B value on the magnetic induction. We want the H. Then what is H? H is equal to, we have formula magnetizing field, that is H is equal to B by nu naught. But B we know in this right now. What is the B on the axis? B is the magnetic induction, but the magnetizing field is the H. H is equal to B by nu naught, but B formula we know magnetic induction on the axis, that is mu naught Ni by mu naught. That is, we know H is equal to Ni. This is the magnetizing field produced by Ni solenoid. Sorry. What is this? N means what? N is the number of turns per unit length. Number of turns per unit length. Okay. Number of turns per unit length. What is I? The current in solenoid. Current in solenoid. Okay? Right. Then, if you want to write the applied magnetic induction formula, applied magnetic induction, okay, applied magnetic field, if you want to write formula, okay, induced magnetic field depends upon intensity of magnetization. If magnetization is more field will be induces, right? Applied magnetic field is, okay, applied magnetic field depends upon, just simply this is applied magnetic field only. Yes, applied magnetic field by permeability. Then we write applied magnetic field as mu naught H. Very simple. Okay, applied magnetic field is mu naught H. And this is about magnetizing field intensity. Magnetizing field intensity. Okay, now take the screenshot and note it, and I will continue the topic after rub. Okay, let us see the next definition. Susceptibility of a substance. What is the susceptibility, and on what factors the susceptibility depends? Susceptibility depends upon the nature of substance. Okay, different magnetic substances are there. In that, susceptibility is the factor whether can a magnet can magnetize or not. Okay, in that how the magnetic field will be produces, that will be depends upon the susceptibility. If more susceptibility is there, then it can be used to make the magnets, right? And let us see here, what is the definition of the susceptibility? It is the ratio between intensity of magnetization, the ratio between intensity of magnetization denoted with capital I, right? And magnetizing field intensity, magnetizing field is called as susceptibility, right? Okay, susceptibility is denoted with psi. Susceptibility formula is intensity of magnetization by magnetizing field. magnetizing field, right? Okay, then what is the definition? Psi is equal to I by H. This is the formula. From this we can also write, if you want I, we write I formula, that is psi into H. This is the important equation. And susceptibility unit, SI unit of susceptibility. No unit, because I is ampere per meter, H is also ampere per meter. No unit and no dimensions. No dimensions, right? Okay. This is our susceptibility. And this susceptibility, on what factors it depends? Susceptibility depends upon nature of material. Nature of material. Nature of material. If I is greater than H, that means magnetizing field is less, but magnetization is more. For small applied field, the magnetization is more induced magnetic moment is there. That means easily it can convert into magnet. For such case, I by H greater than 1 you will get. This I by H is the susceptibility. Susceptibility is greater than 1. If it is there, that is the susceptibility is large. Susceptibility is, if it is large, susceptibility has large value, then such substance used to make magnets, right? Easily convert into magnet. This is importance of susceptibility. Okay, right? Let us go for the total magnetic field. For example, here we are placing the one magnetic substance in the external magnetic field. What is the total magnetic field produces? That way I am going to derive. Okay, take the screenshot and note it. Okay, let us see the total magnetic induction I want to. Look at here in the first diagram, we gave the two diagrams at here. A empty solenoid. This is solenoid, but it is empty. On the axis and the interior of solenoid, nothing is there. Free space is there. Then when the magnet current passes through this solenoid will act as a magnet. One side it will, north pole will generate, and other side south pole will generate. And then it can apply some magnetic field. That applied magnetic field, right? In the empty solenoid, the applied magnetic field will be there. When a iron or any magnetic substance, if it is placed on the axis of the solenoid, this iron, when it is placed in the external magnetic field on the axis of the solenoid, the solenoid applies the field, that is the applied magnetic field. When we place the solenoid when we place a magnetic substance on the axis of the solenoid, at that moment what happens? This solenoid, this iron or anything, it will convert into magnet. It can produce the magnetic field again. This substance also convert into magnet, and it can produce the magnetic field. Then the total magnet, it can produce the magnetic field. That magnetic field is called as induced magnetic field. Then the total magnetic field, this magnetic substance convert into magnet, and after that we can also produce the magnetic field, that is the induced magnetic field. Solenoid applies, that is called as applied magnetic field. Total magnetic field is induced magnetic field plus applied magnetic field, right? This solenoid applies the magnetic field on the magnetic substance. Due to that, magnetic substance convert into magnet, and this magnetic substance also generates the magnetic field. The total magnetic field is the magnetic field, applied magnetic field plus induced magnetic field. That I want to derive. Total magnetic induction formula I am going to derive. Then for that, very simple, that is the applied magnetic field, right? Applied magnetic field. What is applied magnetic field? Applied magnetic field. Applied magnetic field, right? What is that applied magnetic field? That is on the axis of the solenoid. You see the diagram, that is mu naught H, or simply we can also write magnetic field on the axis of the solenoid is mu naught Ni, but Ni is H, we know already, right? And this we write as applied magnetic field is mu naught H. It is nothing but mu naught Ni only. That is applied magnetic field is mu naught Ni, that is equal to mu naught H, where Ni is H. Ni is H. This is equation 1. And now if a magnetic substance is placed in the external magnetic field, at that moment induced magnetic field, right? What is the induced magnetic field? Inside the bar, okay, induced magnetic field is B in, that is its formula. We know already induced magnetic field depends upon intensity of magnetization, right? That is proportional to I. That is induced magnetic field formula is mu naught I. Is that right? Okay, where I is the intensity of magnetization. Then I want the total magnetic induction or the total magnetic field. The total magnetic induction is, that is applied magnetic field plus induced magnetic field. That is applied is mu naught H plus induced is mu naught I. We can common the mu naught at here, we get capital H plus I. Okay, right. And the next I want to change, this is considered as equation 3, but we know susceptibility formula, right? What is the susceptibility formula? I by H. Okay, then according to that we write the I formula. From that we will get B is equal to mu naught of H plus, where we write I formula here. We know susceptibility formula as I by H. From that I is equal to, we write here psi H, right? And then we will get B is equal to, we can common mu naught H also, right? Then we will get 1 plus psi, right? This is the net magnetic induction. This is equation 4. What is psi in this? Psi is the susceptibility, right? Susceptibility of substance which is placed inside the solenoid, right? H is the magnetizing field. We know already H. What is H? Magnetizing field. H is the magnetizing field, and mu naught H into 1 plus psi. Okay, that is equation 1. Next I want the one more thing, that is the relation between the mu r and psi. I want relation between mu r and susceptibility. This is very important. What is mu r in this? Mu r is the relative permeability, that is mu by mu naught. This is permeability. No, I don't want to write this. I will write relation between net magnetic induction formula. We know. Yes, what is that net magnetic induction? From equation 4 we write what we write? B is equal to mu naught of H into 1 plus psi. This is equation 4. And we know net magnetic induction we can also write like this. Net magnetic induction in the medium we write mu H, and this mu we write as mu r into mu naught H. Okay, Right, what is mu r in this? This is the equation 5 and equation 6. You can compare the equation 5 and 6. Compare equation 5 and 6. Okay, mu naught h is there. Then instead of mu r we will get 1 plus psi, right? Mu r is equal to 1 plus psi. This is equation 7. Okay, and what is mu r in this? Relative permeability. Relative permeability. It is just similar to the dielectric constant. Relative permeability formula is mu by mu naught. Mu by mu naught. Mu naught is the permeability of free space. Mu is the permeability of medium. We know it is similar to the dielectric constant in the electricity. Okay, and this is very important relation. Look at here, mu naught, you can compare the equation 5 and 6. BB mu naught h and mu r 1 plus psi. You can compare mu r is equal to 1 plus psi. Relation between the relative permeability and susceptibility is mu r is equal to 1 plus psi. Okay, this is very important and note it every point. Take the screenshot and note all the points. Okay, let us see one problem based on the concept that we discussed today. And now the problem is that a solenoid has a core material with relative permeability 400. Okay, let us first of all, when you want to solve any problem, first of all try to understand the question and write the given values. Relative permeability of a substance they gave as 400, and the winding of solenoid insulated from the core, this winding, okay, we are wounding the solenoid over the core, and now that is insulated. The current carries in the solenoid is 2 amperes, the current in the solenoid. If the number of turns is 1000 per meter, that is a small n they gave as 1000. Okay, turns per meter, 1000 turns per meter. Then after that they give something that they are asking some questions, right? The first question is that A, intensity of magnetization, intensity of magnetizing field, that is H is equal to what? The B question they are asking that magnetic induction, net magnetic field is what? C question they are asking susceptibility of the core is what? D question they are asking that intensity of the questions. Let us see what is this. First of all, A we can solve. Applied intensity of magnetization, we know solenoid applies the magnetic field. Its formula is H is equal to Ni. N is the number of turns, right? We already they gave 1000 into current is 2, then we will get 2000, right? 2000 ampere per meter. H is completed. Next, the second one, B, they are asking to find out the magnetic induction. The magnetic induction formula, net magnetic field, they are asking. There are so many formulas are there. We write directly in the core. If there is nothing is there, the magnetic, if the empty solenoid is there, the magnetic induction is mu naught Ni. This is in free space. Right, empty solenoid. If empty solenoid is there, right, B formula is magnetic induction. Magnetic induction with empty solenoid. Empty solenoid, magnetic induction is mu naught H or mu naught Ni. Mu naught Ni. Okay, solenoid with core, right? Solenoid with core, some substance on the axis. The magnetic induction is, instead of free space we write material core permeability, we have to take mu H. Mu we can also write as mu R into mu naught H. This is the formula. Here we write B is equal to nu H. Okay, B is equal to nu H. Then mu is mu R into mu naught into H. What is mu R? Mu R is the relative permeability of substance 400. What is mu naught? We know 4 pi into 10 to the power of minus 7. Right? What is h? H we got in A. Right? That is 2000. You simplify this. Nearly we will get 1 Tesla. This is C. B completed. Next C. Let us go for C. Susceptibility. Susceptibility formula is what? I by H. This is not suitable because we don't know I. I will search for another formula. Mu r is equal to 1 plus xi. Do you know this formula? From this, xi is equal to nu r minus 1 we write. Mu r is 400 minus 1, then we will get 399. It has no unit. The D problem, D solution is that intensity of magnetization. We have formula for xi that is equal to I by h. From this, I is equal to xi into h, where xi is 399, h is 2000. Then that is, we will get as 2 9 ja 18, 2 9 ja 18, 19 we write, 2 3 ja 6, 6 plus 1, right, we write 7, 7 we write, into, okay, 2 into I did this, 10 to the power of 3 I will write, okay, and this can I also write as 7.98 into 10 to the power of 5. Its unit is again ampere per meter. This we can also write as 7.98 is nearly 8 into 10 to the power of 5 ampere per meter, right? Okay, this is the solution. If you have any doubt, you can ask me. Take the screenshot and note it. Thank you for watching my lectures. Share and subscribe my channel. Thank you.